that the complex cosine, the cosine of z, can be written in terms of the complex exponential in a way that is very similar to the hyperbolic cosine of a real variable being written in terms of the exponential. So this is the hyperbolic cosine with a real variable, and this is the cosine with a complex variable, and we have our exponentials and the 2, and of course the difference here is we have an I times the variable in both cases, iz and negative iz. All right, so let's see if we can demonstrate this equation right here. And we're going to do this using the definition of cosine z and the definition of e to the z. So let's recall cosine of z is cosine of x plus iy, that's our complex variable z. And then this is cosine of x times hyperbolic cosine of y minus I times the sine of x times the hyperbolic sine of y. So that's from memorization there. So we have to memorize this form of the complex cosine function. This is actually the definition, equal by definition. This is the definition of the complex cosine. And let's see, iz, which is our variable here, is I times x plus iy. And the real part of that is going to be negative y. I times I is negative 1, so negative y. And the imaginary part, we have ix. So iz is negative y plus ix. And so similarly, negative iz for this one is the negative of this. So it's positive y and then minus ix. And of course, we need to know e to the x plus iy is e to the x times cisy. Okay, so I think what we can do here is start with the right-hand side and figure out what these exponentials are here and add them together. And let's not worry about the dividing by 2. Let's just take these exponentials and add them together and see if we get twice the cosine of z. So hopefully we'll get 2 times this minus 2i times that. And then we'll be done. So let's look at e to the iz plus e to the minus iz. So e to the iz is negative y plus ix. And then negative iz is e to the y minus ix. Let's add those together. So using e to a complex number, e to the real part, cis imaginary part, we get here e to the negative y times cis x. And then plus, we get e to the y times cis negative x. Okay, so this is, let's just get the real and imaginary parts together. E to the negative y cosine x plus I times e to the negative y sine x. And then we have plus. Now here we're going to be doing cosine of negative x and sine of negative x, since we have cis negative x. So let's just note on the side here that cosine of negative x is the same as cosine of x. The cosine function is an even function. And the sine of negative x is negative sine x. The sine function is an odd function. So we have e to the y times cosine of negative x, which is the same as cosine of x, plus I times e to the y times the sine of negative x, but the sine of negative x is negative sine x, so this should have been a minus sign right here. Let's fix that. Let's make that a minus sign. Okay, now let's collect the real parts and the imaginary parts. The real part looks like we have a cosine of x times an e to the y here and e to the minus y here. So I'll put e to the y first plus e to the minus y. And then we have plus, or do I want to write a minus? I think I want to write a minus because I want it to look like that. So I want this one to be a minus. Minus I times, and then the imaginary part has a sine x. And since I put the minus there, this one will be an e to the y with a plus, and this one will be an e to the minus y with a minus. Okay, and now hopefully we can see it. We have cosine x, that matches. And now e to the y plus e to the negative y, this is twice the hyperbolic cosine of y. The hyperbolic cosine of y would have an over 2. So here we don't have an over 2, so we have twice the hyperbolic cosine of y. And then we have minus I. Here I'm copying, and it's matching, minus I sine x. And then this one is the hyperbolic sine, except the hyperbolic sine has it divided by 2, so this one is twice the hyperbolic sine of y. And then we can factor out the 2 and divide it to the other side and write the final form. E to the iz plus e to the minus iz, all divided by 2, equals, divide this by 2, and that will cancel out that 2 and that 2, and we'll be left with cosine of x times hyperbolic cosine of y minus I times the sine of x times the hyperbolic sine of y, and this is the cosine of x plus iy, which is the cosine of z, and that is the equation that we wished to demonstrate. The complex cosine being written in terms of the complex exponential in a way that is very reminiscent of the definition of the hyperbolic function here.